Hello, Maurieos cul-de-sac 10, cross sections. In this video, we will be having a look at cross sections. So first, let's just have a look at the final product. So these are a series of cross sections along the alignment chainage. It's usual to start at the lowest cross section and work up the page. Sometimes it's possible to have a set of cross sections going up each side of the page, but my investigations have found out that in order to fit the width of them in, that I need to have just a single row of cross sections. So on this page we've got cross section at chainage 20, 40 and 60, and just to zoom in you can have a look at very simply. They just have the design offset, which is left to right. So the left offset is shown as negative and the right offset is shown as positive, always from the centre line of the road as indicated by the CL for centre line here. The existing ground, that's the height of the existing ground, which is through here, and the design height, which is obviously the height of the centre line of the road. I've chosen to stay with the height above datum of 23, so that will put these cross sections in with the same height of datum as the long sections. So it's just really a simple matter of plotting the existing ground level through here and then placing the cross section, and in most cases that will be the typical cross section. So it's just a matter of copying that in at the right level. And I have these here indicate the boundary, as we know from the typical cross section, and from the boundary back up to the natural ground I'm going to have a 1 in 10 or a 10% grade back up into the sections. You can see that this cuts the road down into the land, which this will provide sufficient ponding for stormwater and such, and will ensure that the houses on the lots all sit above the road level, or for the most part above the road level, which is always a good thing. Just by way of sort of going into the future, we will be able to use a polyline just to work out the volume or the area of these cross sections. From the area of the cross sections, we will be able to determine the volume of earthworks, or approximate volume of earthworks for this particular scenario. You'll note out here that the ground height and design, and that the ground height and the design height are the same, obviously, because that's where they design height and existing ground will have the same height at this point here. And this distance out here, having determined that from the cross section, will enable us to plot that onto a plan view, and that will give us this point here as the edge of the earthworks, as being natural ground out here and the earthworks commencing in here. So how do we do this? How do we get and plot these up? Well, I've created a tab in here where I do all my calculations, and it's this one here. If I just get out of the pan mode there and go to here, and this is my model space, and just this is the actual true area here that plots in for plan view so that the coordinates are correct. You'll see here that I've actually I've gone ahead and drawn in the earthworks at this point, and that will be the subject of the next video. But in terms of calculating the cross sections, there are a number of approaches that we can use here. Probably essential just to quickly run through. The cross sections are always at right angles to the alignment. So here is cross section 20, and very simply that's at right angles there. Obviously the alignment in this place is heading 90 degrees, so that will have a bearing of 0 degrees. So here's cross-section 20 and 40. When we get to cross-section 60, that is on the horizontal curve, so the cross-section runs on a line from the curve, a point on the curve, through the centre of curvature, because remember that a radius is always perpendicular to the tangent. So the tangent at that point, the radius, would always be perpendicular to the tangent at the point. So for the cross-section 60 and 80, which are both on the horizontal curve, we run the cross-section line goes back to the centre of curvature. And then we come up here and we can see in here is 80 is in the curve, 60 and 80 is in the curve, and then 100 is on the straight coming out of the curve, and again we're at just go at right angles to the alignment, and so on. So there's a number of ways of drawing the cross sections. You can of course document just using the dimensioning tools. You can document the intersections of the cross-section line with the particular contours. You could perhaps note that down into a Excel spreadsheet and then just plot up the cross-sections like so. And so I've dimensioned them there, and then you can see that that's the, that's the 27.246, so 27.6, 27.8. You could do that there. But what I've tended to do is to try and draw them live in here. So say for instance, I know that my height of datum is going to be 23. So here's my cross-section line here. Here's where it's intersected this particular one is intersected the 28.6 contour. So what I've done there is I've drawn a line at right angles to the section line, and that will be 5.6. So my height above datum is 23 plus 5.6, 28.6. And so I've drawn that one there, and I've drawn a similar one here, and then joined them up with a polyline. I have also tended to, just for to keep things real, gone back to the long section. So this is cross section 80, this one that we're doing here. So I've gone back to the long section there and just had a look at cross section 80, and you can see that at cross section 80 the design height the ground design height will be 27.32 and the ground height will be 28.65. So I have actually on my calculation sheets here put in the ground heights at 28.65, I'm hoping, or close to that. So I'll just have a look here. So this is the 80. I've just plotted this line here, and it's not coming up for some reason at this point. Oh, I've included it included it into a polyline, joined it together for a stage later on. So I'll just do a quick dimension here, perhaps, and see what we get. So 28. Not quite what I was after. We'll have to review that. But this distance here, which is the existing ground or level, I've put that in there and then drawn a polyline through there. Then what I've done is I've taken that, copied that over to my cross-section area over here, cross-section 80 I think it was, and yes, cross-section 80. I've transferred that over to here and then rotated it round to be at right angles to this little base that I've set up here with the design height. So I've able to set those up and then rotate the the cross section as required. And then we can, to determine various dimensions that we need. So if we look at this one here, 6.471, so that's 23 plus 6.471. Here's our dimension across here, which we can determine once we load in. Just make a copy of the typical cross section and then extend or trim the 10% lines so that they fit in with the natural ground. And that's how that all works. Now these calculations here, they're done in a particular layer. I think I've used the cross-calc layer for those, or what I call a cross-calc layer. And I'm able to have that layer on in this viewport, but when I go across to the other viewport, to the real life viewport, I have it turned off, so these dimensions don't show up. Just of note in this last one, this is chainage 154.366, and that one there, that's through the cul-de-sac head. So I've had to adjust the cross section here to get the 10 metres of width that we get from the lip of channel through to the from the centre of there to the lip of the channel, the 10 metres there for that particular one. The rest of all of the other sections, they're all just use the typical cross section, so it's just a matter of either making the typical cross section here, just copying that, and then adding the 10% batters for up or down, but these are all up from the boundary, just adding those in to each cross section. So then we very carefully put the cross sections in order. I've worked out that I can get 3 on the first page, 3 on the next page, and 2 on the last page, so I've spaced them accordingly. Typically the centre line, you would run a line through the centre line so that they would all be on the same line, so that when you go to the actual lines or sheets of these, you can get a bit of an idea, if you look at it a certain way as to what the road's doing. So it's sort of getting deeper as we go through here. So there's cross section 1, cross section 2. So I've done it just every 20 metres. In this case, the cross sections are all fairly similar. We can see here that I've got some information here that shouldn't be showing up here. That's because it's in the 0 layer, which I've got turned on. So I'll just put that into the cross-calc, what I call my cross-calc layer, and that just turns it off in this particular viewport. And then we go to our third one there, and again I've put some more dimensions in there that I'll just go to model space and put them in there, like so, and like so. And I'll just put those in the cross-calc layer that'll turn that off. Coming up, there it is, cross-calc. And there we go. So cross sections, I've kept them fairly simple, but you can get a bit of an idea of what's happening, what's going on, and in particular you can get these critical dimensions here, here and here, which then can be plotted, and I've started to do a little bit of this. Those dimensions can be plotted onto the earthworks plan. So here's cross section 20, and there's the dimensions in there, and so on. And by plotting those dimensions and dimension out the end of the cul-de-sac from the long section, we're able to get a bit of an idea on where the edge of fill is, and then we'll have a look at seeing how the design contours go and working out a volume. So that's the subject of the next video. So there you go. Thank you, and enjoy the rest of your day.